So hello and welcome back everyone. Today we'll solve the problem number 38 of LeetCode, which is count and say. Now the problem is pretty easy, but the problem in this question is that the description of this problem is a little bit confusing, but the solution of this problem is very easy. So we'll first try to figure out what this problem wants to say, and if we are able to think or we are able to understand the description of this problem, then the solution part of this problem will definitely be very easier for us. So let's start with the description of this problem. Okay. So as the name of the problem suggests, count and say. So, okay, we need to count something. We need to count something. And then what we need to do? We need to say. We need to say something. So this is what we have just deduced from the name of this problem, which is count and say. So we are saying that we need to count something and then we need to say something. Now let's figure out what we need to count and what we need to say. So okay, let's start with the description of this problem. The count and say sequence is a sequence of digit strings defined by a recursive formula. Okay, so the question has given us the hint that this is the problem of recursion. How? Because they've already given some recursive formula to us. So, okay, this is first that what we have deduced from the name of the problem itself. The second thing that we know now is that this is the problem of recursion. Okay. Another thing that we have already figured out just reading the first line of this problem. Now third thing what we have is they have given that count and say of 1 is string 1. Okay, so we have some function whose name is count and say, and it takes the input which is integer, and for the integer n we have the output as string 1. Okay, so this is something that we have already given in the question. So doesn't it seems like a base case? Because base case is what? We need to actually stop a recursive call at some input, and we usually return something at some fixed or some known input. So for this case, we already know that for the input n, we need to return a string whose character is only 1. So for the integer n equals to 1, what our function is returning? Our function is returning a string 1. Okay, so this is something which we will also require. So this is the base case that we already have in the problem. Okay, so this is the third thing that we have already discovered in this problem. Now see the main part of this problem, this is statement. So what they are saying is count and say of n is the way you would say the digit string from count and say n minus 1, which is then converted into a different digit string. Okay, so they are saying that let's say count and say, we are naming count and say is f of n. Okay, so f of n is the way you would say the digit string from f of n minus 1, which is then converted into a different digit string. Now what is digit string? Digit string is nothing but a string whose characters are what? Whose characters are ranging between 0 to 9. Okay, so this digit string is nothing but the string whose characters range between 0 to 9. Now see, what is happening is that f of n is the way you would say the digit string from f of n minus 1. So okay, what they are saying is that f of n is a way in which we will say a digit string. We are saying a digit string. Okay, f of n is actually saying a digit string. Now where this digit string comes from? This digit string comes from f of n minus 1. Okay, so f of n minus 1 is giving a string to f of n, and then f of n is saying that digit string. So this is given in this statement. Okay, saying the digit string. Now let's again try to understand what they are trying to say. That f of n minus 1 is returning a string to function. F of n minus 1 is returning a string to f of n, and then f of n will say that digit string. Now we don't know that how to say that digit string, but we now know that where does the string comes from. Okay, so a string comes from f of n minus 1, and what will f of n do? F of n will actually say that digit string. Now see, they have also given that how we need to say that string. To determine how you say a digit string, split it into minimal number of substrings such that each substring contains exactly one unique digit. Okay, so what we need to do is that to say a digit string. Okay, so let's say we have a digit string as we have given this digit string 3 3 2 2 2 5 1. Okay, So we have this digit string given in the question. Now we don't need to worry about that how this digit string comes from and who is returning this. We already know that this string would be returned by f of n minus 1, but we don't need to really worry about this, that how this digit string is generated or something like that. We'll do that in the coding part, but for now we are just trying to figure out that how we will be saying this digit string using some kind of things. Okay, so what we have is, to determine how you say a digit string, split it into the minimal number of substrings such that each substring contains exactly one unique digit. So what we need to do is, to say this digit string, we first need to split it into substrings. Okay, we need to split this string into substrings. Now, like how can we actually split this into substrings is that we need to actually split this string into substring in a particular way. And what is the way in which we need to split this string is that we need to split this string in minimal number of substrings such that each substring has unique digit. Okay, so this is how we need to split this digit string. Okay, we have the digit string. Now we need to split it into a substring, and during the splitting we need to ensure that this point is always valid for any of the substring. Now what does this point is actually saying to us is that split the digit string in such a way that each substring has unique characters, which means that in a particular substring that we are splitting, all the characters of that substring are same. Okay, so if we try to do that in this substring, what we can do is that we first split this string in this part, and for this substring we have the unique character 3. Then we will split this string in this part, and for this substring, what is the unique character? We have 2. Then we need to split this string in this part, and in this substring, what is the unique character? 5. And lastly, what we have? This 1. And again in this substring, we have this 1 as the unique character. So now we have successfully splitted this string into minimal number of substrings such that each substring has unique digit. Okay, so in this substring, what is the unique digit? 3. In this substring, what is the unique digit? 2. In this, let's say this is the substring A, this is substring B, this is substring C, this is substring D. So in substring A, what is the unique digit? 3. In substring B, what is the unique digit? 2. In substring C, what is the unique digit? 5. And in substring D, what is the unique digit? 1. Now, what does this minimal number of substrings actually mean? See, this is one way of splitting. If we try to split it in another way, we can do something like this. Okay, just try to understand that what am I saying. We can also do this kind of splitting. Okay. Now we have how many number of substrings? A, B, C, D, E, F, and G. So we have in total 7 substrings, and each substring has a unique digit. For A, we have a unique digit 3. For B, we have another unique digit 3. For C, we have another unique digit 2, and so on. But is this the minimal number of substrings in which we can split this digit string? No, because we have this as the minimal number of substrings in which each substring has a unique digit. Okay, so we need to ensure that after splitting, the substrings that we are forming are minimal in numbers. Okay, so I hope that I am able to convey what is the problem saying. Now this is one part. Now what we need to do further is that, see, we have already splitted this 3, 3, 2, 2, 2, 5, 1 substring, and this 3, 3 plus 2, 2, 2 plus 5 plus 1. Okay, so this is the splitted version of this string. Now what we need to do is that, see, let's read the description. Then for each substring, say the number of digits then say the digit. Okay. So what we need to do is for each substring, we first need to say the number of digits and then we need to say the digit. What they are actually trying to say is that, see, for in each substring we have unique digits. In each substring we have only a unique digit. Okay. So what we need to first say is the frequency of that unique digit in that particular substring. Okay. So what is the frequency of 3 in this substring? The frequency of 3 in this substring is 2. And what is the digit? 3. What is the unique digit? The unique digit is 3. 2 is the frequency of the unique digit and 3 is the digit. So this is the frequency of the unique digit in the substring, and this 3 is the digit itself, unique digit itself. Okay, unique digit. Then for this substring, what is the frequency of the unique digit? 3. And what is the unique digit? 2. Okay. Then for this substring, what is the frequency of unique digit? 1. And what is the unique digit? 5. Then for this substring, what is the frequency of unique digit? 1. And what is the frequency and what is the unique digit? 1. Okay. So we have now said what we need to say. Now what they are saying is finally concatenate every said digit. Okay. So finally, after doing all these same kind of things, we actually need to concatenate all of this. Okay. So what we get finally is 2, 3, 3, 2, 1, 5, 1, 1. This is what we will be left after doing all the part of this problem. Then this is the substring that is returned. Okay. Sorry, this is the string that a function or count and say function will return to its recursive call. Okay, count and say. Let's say this is the result for count and say n minus 1. So this string will be returned to which function? Count and say of n. Okay. So this is something that we need to do in this problem. Now let's discuss how can we do this. So let's start with some case n equals to 3. Now for n equals to 3, do we have any string which we can say? No, we don't have any string. Okay, see, we only know that for n equals to 1 the answer is this 1. Okay, we don't know for n equals to 3 what is the answer. So how can we return anything to the solution or to the question? We cannot return anything. So we first need to calculate what we need to return. So we'll say, okay, n equals to 3 function will say, I don't know anything. So I'll call n equals to 2 function and I'll ask n equals to 2 to calculate the result for me, and then I will do something so that I can return that value to the solution, to the question. So now the call goes to n equals to 2 function, f of n equals to 2. Now f of n equals to 2 will also say that I don't know anything. So because I also don't have any kind of string with me. So now I'll call another function which is f of n equals to 1, and I'll ask that f of n equals to 1 to calculate a result for me, and then I'll return it to n equals to 3. So n equals to 1 will say, okay, I am the base case, I know what is the answer for me. So it will simply return what? N equals this string 1, which is already given in the question. So now n equals to 2 will say, okay, now I have this string. Now if we recall, what is f of n do? F of n actually says the digit string that it got from f of n minus 1. Okay, so f of n minus 1, which is f of 1, has returned this digit string to f of n equals to 2. Now what will f of n equals to 2 will do? It will try to see this string. Now how can it say that this string is? It will first split it into the minimal number of substrings with unique digit. So after splitting, this string will look like this. Now in this string, what we were doing is that first we will write the frequency of the unique digit, which is 1, and then we will write the digit itself, the unique digit itself in the substring. So this is 1. Then we concatenate and return it to the function. So this is the final result for n equals to 2, and this result is returned to n equals to 3. Now n equals to 3 will try to say this string, and this string is 1 1. So how can we split this string? Again, in this way, this is the minimal number of substrings with all unique digits. Now how can we say this? First we will say the frequency of the unique digit, which is 2. Then what we will say? We will say the unique digit, which is 1. So this is the final result that n equals to 3 will have, and n equals to 3 will return it to the main function. So what is the answer for this question is 2 1. I hope that I have been able to clarify all the doubts and to show that how is this all the working has been done. So let's try to do this for n equals to 4 also. Okay, so let's say n equals to 4. Now see, first call will be for f of 4. Now f of 4 will say that I don't have anything, so how can I return or say anything? Because f of 4 doesn't have any string, it just simply have this f of 4 which is integer, and for integer it doesn't have any kind of string within itself. So how can f of 4 will say anything? F of 4 say that I don't know anything, I don't have any string, so I will call f of 3 so that it can calculate a result for me, and the result that I will get from f of 3 I will try to say that string, and then I will return it to the main function. So the call will go for f of 3, and f of 3 will say okay, I also don't know anything, so I will call for f of 2. Then f of 2 will again say that I also don't have any string, so that I can say that string. So f of 2 will call f of 1. Now f of 1 is the base case, which is already given in the question, which is f of 1 is this string 1. So f of 1 will return a digit string 1 to f of 2. Now f of 2 will try to say this digit string. Okay, so how can f of 2 will say this digit string? It will first split it into the minimal number of substring with unique digit, which is nothing but 1 only, and then what it will say is, firstly it will say the frequency of unique digit in this substring, which is 1. Then it will say the unique digit, which is again 1, and it will return this substring to f of 3. Now f of 3 has a digit string from its f of n minus 1, which is nothing but f of 2. So now f of 3 has a digit string f of 3 as 1 1. F of 3 has a digit string 1 1 with it. Now f of 3 will try to say this digit string. Now how can f of 3 will again say this digit string? See, is this the minimal number of substring in which we can split this digit string? Yes, definitely, because in this 1 1 we have all the unique digit as 1. So f of 3 will try to see this, and what is the frequency of 1 in this substring? 2. And then what is the unique digit? 2 1. So this is how f of 3 will say this digit string, and this string is returned to f of 4. Now f of 4 has a digit string from f of 3, and f of 4 will try to say this digit string. And how can we split this digit string into a substring with minimal number of substrings such that each substring has unique digit? So we can have something like this, 2 plus 1. Okay, now what is the frequency of unique digit in this substring? 1. And what is the unique digit? 2. And for this, what is the frequency of unique digit? 1. And what is the unique digit? 1. So this is how f of 4 will say this digit string 2 1, and after concatenating this we will get 1 2 1 1, and this is something that we would like to return to the main function. Okay, so I hope that you have understood the flow of the code. Now let's try to think that how can we actually build an algorithm for this, for what we need to do. Okay, so I hope that we have already understood that count and say, first call n minus 1, count and say of n will firstly call f of n minus 1, and the string that it will get from this function, let's say this f count and say of n will get a string 10 from count and say of n minus 1. Then this that what we need to do is, this is the digit string that we are getting from count and say of n minus 1. Let me write this clearly again. What is happening is, see, count and say of n is calling count and say of n minus 1. Okay. And this count and say of n minus 1 is returning a digit string, and this digit string is then set by count and say of n minus 1. So we'll write another function, let's say a function, in which we will pass this digit string so that it can return a string in which this f of n is trying to say that digit string. Okay. So what is happening is that, let's say we are storing this string, digit string, which is coming from count and say of n minus 1 for count and say of n. Okay. Now we'll call another function, let's say function, in which we will pass this digit string, and this digit string, and this is the answer of our question that we will return. Okay, so we'll then return this answer. Now we have already seen that the base case for this count and say of n minus 1 is n equals to 1, in which we will return this 1. Now what we need to think is that we need to find an algorithm to say this string. Now see, again we will go back to our question 3322251, which we had in the question only. Now let's see how can we say this. So we'll just simply traverse in this digit string. Okay, so we have a I pointer here, and we'll run a loop, while loop, let's say, while I is less than n, n is nothing but the size of or the length of this string, this digit string. And in this digit string, we'll first mark a character, let's say character ch, and this is s of I. Now see what we will do. We'll initialize another variable, which is count, and count is the frequency of this ch in the substring. We are not actually trying to split this string, but we are just trying to calculate the frequency. Okay. Now see how can we do that. We'll run another while loop in this, and we'll say while s of I is equals to ch, just increase the counter, which is nothing but the frequency of s of I in the substring, and we'll also increase the I pointer. Okay. See, now for this I, what is the ch? Ch is 3, and count is 0. Now for this while loop, what we are looking for is, we are looking for this 3 in the substring. So currently I is here and ch is again 3. So we'll say, okay, we have seen this 3, or s of I is 3. So we'll increase the counter by 1, and then we will also increase this I. So now our I points to this index 1. Okay. So at index 1 we again have 3. So this 3 will match with this character in this condition, and we'll again increase the counter, and then we'll increase our I pointer. Now we don't have 3 anymore, so we'll come out of this loop. And now what we need to do, we already have the frequency of 2. We now already have the frequency of this unique digit in the substring. So what we need to do is, let's say we have some string answer here also in the question, and we just need to push all those frequency and characters in this substring. So we'll just simply add this answer plus equals to, or let's say answer equals to answer plus what we first need to do is, we first need to convert this frequency, because this is an integer, so we just convert this into a string. So let's say this is a string. This is not the actual way in which we can convert this into something like this, but okay, this is something like pseudocode only. So a string of count, because we first need to say the frequency of the character in the substring, and then what we need to say is the character. So this is how we will code this up. So now let's try to code this problem. See, we have an int. What we have is we'll first write the base condition, base case actually. So if n is equals to 1, what we will return? We will return this 1. Okay. Now for if we don't have 1, we will get something from let's say this is the temporary string, which we will get from count and say of n minus 1. Okay, and then we need to say this string temp also. So how can we say that? We can say that using another function, and we'll store that string in a string answer. And let's say that the function that will actually say that string is say function, in which we'll pass this string temp, and what we finally return is answer. Return answer. Now the only part of this problem is to write the say function. So we'll try to write this say function. String say, it is taking what? It is taking a string as an input, which is, let's name it as temp. Now what we were doing is we were actually making a string, let's say answer, empty string answer. Now we are running a loop to traverse the temporary string using the index I, which is equals to 0, which is pointing at the 0th index of the temporary string at first, and int n is the, okay, let's leave it. We'll just simply try to do this with using this only, while I is less than temp dot length. Okay, and in this loop we will say, okay, first mark the unique character. Okay, mark the unique character. Now how can we mark the unique character? We will say the s of I is the current unique character. Now what is the count of the unique character? Because we have not actually seen this character anyway, so we will start the count or frequency with 0. And now we'll try to see that what is the frequency of this character in the substring. So we'll say if s of I is equals to ch, then frequency plus plus and I plus plus. Now by this while loop we have already calculated the frequency of the unique digit in the substring. So what we will do is that answer equals to answer plus, see, we need to convert this into a string first, so we'll convert frequency into a string. Then we will just simply add what? This character. Okay, so now this is good here, and lastly we will push what? Answer dot push back what? Character. So this ch, and after completing this or traversing for the whole thing, we'll just simply return this answer to the function, to the count and say function. Okay, so let's run this code first. Okay, s of I, what is happening? Okay, we have this temp here, so temp of I. So yeah, it is working. So let's try to submit this. And yeah, this is expected. This is accepted only. This is accepted. So hopefully you have already understood the problem. And if you like the solution or you have understood the problem, then please like the video. Thank you.